So thanks a lot. So thanks a lot to Jean-Marc and Stephanie and Lucy for organizing, and for Matt to be here, and for the Georgetown to support this event. So I'm going to present joint work with Sergei Guriev, Theo Marquis, who's a postdoc here at Sciences Po, and Katya Zuraskaya at PSE. It's going to be a paper about policies to fight circulation of false information, and that's the first goal. And the second goal is actually to estimate structurally the motivation for people to share on networks. So what drives people's decision to share on networks, and how these policies impact this sharing decision. So being part of a network conference is a bit of an abuse, because the paper does talk about social network, but the network structure is really in the background. So if you're a network fanatic, you might be frustrated. But Matt isn't a network fanatic, so so that'll be fine. But it's going to talk about the reasons why you circulate information in networks based on a survey experiment. So there's been a general interest on the question of circulation of false information. A large share of the population now gets information from social media. It's about 35%. And we know that there's a significant amount of false information circulating on these networks. And many papers now have established impacts, be it on political outcomes, so outcomes of elections where it's still disputed, instigating hate crimes, but importantly on health outcomes. So there's a large evidence that the circulation of false information has impacted health decisions and protection decisions, in particular in the context of the COVID crisis. So there's a general interest in the question, but there's really a lack of understanding on the fundamental element, which is what drives people to share news, actually false and true. Okay, what drives people to share information? So to fight this circulation of false information, there's been proposals of long-term solutions. So regulation of platforms is the first one, with, in Europe, regulation that's been put in place. And other long-term solutions that I would call digital literacy training, which is to train people to understand how to detect false information or to be more aware of the characteristics that they have. And then there's been all these short-term, what I call short-term interventions, that have been implemented by social media themselves. First of them is fact-checking. So there's collaboration between some social networks and fact-checkers to verify the information. Second, there's everything that slows down the process, asking people to confirm their intention to share, making extra clicks, pause, frictions in the process. And finally, there's all these methods of nudging, which have been pushed by, in particular, Pennycook and Rand, so a large literature coming from psychology, pushing for priming social and reputational concerns when you share. And so all these different interventions and policies have been evaluated in a wide array of contributions. But I think they suffer from a number of limitations. So first of all, and most importantly for me, they all rely on reduced form analysis. So it's typically survey experiments or different form of interventions. And it's hard to understand the fundamental mechanism that make these policies work or not work. And more importantly, we have the missing piece of what drives people to share in the first place. Okay? And second, they typically compare these policies independently and tend to focus on the circulation of false news, whereas you're interested on how these policies would impact both circulation of true and false. So what we're going to try and do in this paper is to first use a randomized survey experiment on Twitter to study the impact of these policies on the circulation of true and false news. So that's the first piece. So we'll have the average treatment effect that comes out from this randomized experiment. But then we're going to use this experiment to first propose a model of sharing decisions. What drives people to share? And we're going to have a model where people update on the characteristics of the sender based on the decision to share information. And this model, we're going to be able to recover an indirect utility function that we're going to estimate using the data from the experiment, and then do simulations to understand first why did the different policies work? And second, what can we say about other policies, such as digital literacy training? So that's a bit the idea of what we're going to do here. Okay, so let me first start with the experimental design, show you the average minimum effects, and then we'll go to the model and the structural estimation. So the experiment was conducted during the US midterm elections in 22, before the US midterm elections. We've been actually just been doing a large-scale replication of this during the current presidential elections. And we actually have people that were contacted through an online platform, okay, that arrived on that platform. We restricted to Twitter users. But then the interactions would, in the end, happen on Twitter, as I'm going to explain right now. We had 3,000 people participating in the experiment. So these are the main phases of the experiments. So first, we collected the number of pre-treatment characteristics on the platform on these people, in particular, their political alignment, okay, trying to identify what their political leaning was. Second, participants viewed political content on the platform, so as these were screenshots of the actual tweets. But then they were brought to Twitter to actually see the tweets on an account we had created. So I'm going to explain that. Then the people were exposed to different treatments that correspond to the different policies that I mentioned in the introduction. And they were then offered to share one of the tweets, or none at all, on Twitter. And finally, which is an essential element for the estimation of the model later on, we asked participants to evaluate the characteristics of each of these tweets that they were faced with. So they had to evaluate the veracity of each tweet and the partisanship of each tweet, as I'm going to explain right now.
How do you select the people?
The people who participated, so we asked for so it's people that are provided by this provider of samples. Okay, so and we asked for a balanced sample, representative of the US population, but not necessarily representative of the Twitter population, but representative of the US population.
But
okay?
Maybe you're not going to get those who are the most stubborn.
Absolutely, absolutely. So you're probably not going to get sort of the bubbles of the most extremists and the reason why these people share. But then I think you can consider this population might be more, less extreme, but they still matter in the process of circulating this information. As we're going to see, it's not that they're completely immune to sharing them, and so they are connectors that might connect these communities of extremes together. Okay? But I'm not going to extrapolate on what we would learn on these more extreme communities. It's going to be based on this sample. Yeah.
But they still needed to have a Twitter account.
Yeah. They all needed to have a Twitter account. So if they didn't have one, they were logged out of the experiment immediately. So they all had Twitter. It's just they're not, first, not representative of Twitter population, and second, they're not the most extreme elements on Twitter. Okay, so how were these tweets presented? So participants were presented with 4 tweets sequentially in random order. And as I said, the screenshot, they saw a screenshot within the survey experiment. And there was a link to Twitter where they could see the tweets on an account that we had ourselves created before. And that for several months before the election had been posting news from both liberal and conservative media, so a sort of balanced process of posting, selecting the most popular news for each day and doing several postings per day. So it was an active account where we posted these four tweets that on the day of the experiment. So this is what the account looks like. So it was regularly active, and on that day we posted these 4 tweets that were used in the experiment. So what were these tweets that we chose. So here I'm not going to make any claim of generality of the tweets. We had a selection process that led us to choose these tweets. So we chose two false tweets that were content that were fact-checked by an independent NGO, a fact-checking organization called PolitiFact. One was on societal issues, and one was on economic issues. One was a priori favoring Republicans, and one was favoring more Democrats. Okay? And then corresponding to that, we had two true tweets from those that were selected by the account's algorithm. So again, one cultural issue, one on economic issue, one pro-Republican and one pro-Democrat. Okay? Importantly, what's going to be really key in the structural estimation is not necessarily the average veracity of these different tweets, is the perception that people have of the veracity. So each individual is going to report for each tweet whether they think how likely they think it's true or false. Yeah?
And you're pretty clear that PolitiFact is correctly coding things as true or false, because I just noticed that on social media, lots of people say this is they get very angry if something is false, but it's basically there's a judgment that is basically a very, very ridiculous judgment.
Yeah.
So
Okay. So establishing truth is always a big question. PolitiFact is sort of the dominant player and focusing on political issue and is rather careful in the claims. I think the biggest claim that people make against fact checkers is sort of the selection process, is who they target when they select the news, not necessarily the conclusions that they reach. That's most of the. So I'm relatively confident on that. Again, what really matters for me is how people perceive this information, whether they perceive it as being, how likely they perceive it to be true or false. But yeah, it's one of the dominant players in importantly, there was no attribution to the original source that was provided, so these tweets were posted on the account as if posted by this independent unit. Okay, so let me now give you details on the experiment. So, sharing phase, so participants, after having viewed the tweets and being exposed to the treatments, chose whether to share one of these tweets or none at all. Okay, so it was a maximum of one. They were reporting the intention on the survey webpage, and then they were brought to Twitter to eventually do this sharing on their account. What we're going to use in this experiment is the decision that they report on the platform of whether they want to share the information or not. Okay? So that's the sharing decision that happens after the treatments. So what are the treatments? So we're going to have 5 treatments that correspond more or less to the policies I mentioned, the short-term policies I had mentioned to you initially. So the first treatment is the control group. They don't see any, there's no intermediation. They just see the tweets, random order, and then choose which one to share or none at all. Second is require extra click. So we ask people to confirm that they really wanted to share once they had reported the intention to share the tweet that they selected. Third is this nudging type procedure. They're called prime fake news circulation. I'm going to show you what it looks like. Fourth was offer fact check, propose a fact checking. And fifth is asking them to assess the characteristics of the tweets before doing the sharing decision. Yeah?
So I'm wondering about the baseline. They still kind of being monitored a little bit. So I'm wondering if it's going to reduce the sharing of false news with respect to the user, the Twitter user being on his account, because they're part of this survey.
Yeah. So they feel definitely it's not going to be exactly as if they were in the natural environment, because they originate from the survey, so they know that they're going to be observed in doing that. So there could be some experimental demand effect in the observation. But what we're going to really exploit here is first individual variations, and second is the treatment effects, which should be a priori independent of this. But again, I don't want to make excessive claims, as in within any kind of experiment where people are contacted, there's going to be a sense of being observed. Yeah.
Just to be clear, so on your survey, they give their intention to share, and then some do it effectively, some don't?
Yeah, exactly. So to be more precise, so they asked these 4 decisions. They reported here. We can share at most one of them, and then they brought to Twitter itself to confirm their intention. Okay. The fact is, not everyone eventually confirms. So there's the transformation, because each step that you make makes a next step where you lose people, because we even have a third step where we ask them to confirm. So there's much less sharing, eventual sharing on Twitter than we have on the initial page. What I'm going to show you are the results with the decision reported on the platform. The final decision gives...
When you say platform, it's your survey.
Yeah. Sorry, our survey platform. So the survey question. The results with the final decision hold up, but are much more noisy.
But it also means that your extra click is already in your design.
Yeah, in a sense. They don't realize it on the first decision, but in the design for the final sharing, it's already in the design. Mm-hmm. So that's another reason why we prefer using the initial survey decision. Okay, so let me show you these different treatments. So the nudging is extremely simple. It was something proposed by this team, Pennycook and Rand, and many different contributions. We have different versions of this. Very simple. You just tell, be careful before you retweet. Remember that there are false things circulating. So it's a simple nudge. It's very, very non-costly to implement. Okay. Offer fact-checking, it tells you for 2 of the tweets that were shown to be false, you can go and see a fact-check of the content. Okay? So it means that people can know that 2 of them are going to be not fact-checked. So they even on those that are not fact-checked because true, they can make inferences. Okay? And plus, even if they don't go and see it, they already have a signal that something might be wrong because they see that this thing has been fact-checked and proven to be false. Okay? So that's a classic fact-checking treatment where people can access, are told that 2 of the elements are wrong. Okay? And finally, in the 5th treatment, we ask them to assess the characteristics of the tweets before, of each tweet, before they decide to share. Okay? So we ask them to first evaluate the veracity of the content. So guess the probability that the tweet is true between 0 and 100. And this they have to do for each individual tweet. So each of the 4 tweets, we're going to have an individual observation of how much they think the information is true or not. Second, we ask them, how do you feel, what is the partisan bias of the news? And we ask them on a scale of 1 to 5, do you think the tweet is more likely to favor Democrats or Republicans? For all the participants except in the 5th treatment, this decision is asked after they share. We added this treatment to make sure that there was no motivated beliefs in the way they reported it, in the sense that the decision to share did not influence the way they would evaluate the characteristics of the different content. And it turns out that there's no effect. Okay, so these characteristics were done individually. Yeah.
You didn't elicit any feelings about the veracity of the fact checking.
No.
Because I can imagine that a lot of fact checking organizations are partisan.
Yeah.
And so you might.
Yeah. So you'll see. But I'll show you all the evidence on how people update afterwards. You'll see that people don't update that much after being exposed to fact-checking, and there's quite an element of heterogeneity that could capture some of what you're saying. But we didn't actually directly ask them what they think of the fact-checking organization itself. Yeah. So first, on these, as I said, at the end, you ask them to evaluate these characteristics. And these are the average, so the scale here is the veracity between 0 and 100. The colors, by the way, I respect the choice of Sergey and Katya, who wanted to support Ukraine. So, but visually it doesn't look great on the slides, but I stand by the support. So 36% of the veracity, the estimated veracity is much lower for the false than for the true. So people are not, in that experiment, in the context of these particular tweets, people are quite good at differentiating true from false. This is in the control group. Okay? And they're also pretty good in evaluating the leaning of the tweets. Democratic tweets are judged more favoring Democrats, and the Republican tweets are more judged to favor Republicans. Yeah.
In the control group, does the sharing align well with the veracity, or do some say, I think it's false, but I'm still sharing?
So that I really go, because then I'm going to propose to you a model of why people share, and then I'm going to go back to these individual characteristics to show how they influence sharing. So that's going to be the structural estimation. So I'll give you the answer to that. Yeah. Veracity does count, but let me postpone. Yeah.
It's very, very tiny standard error.
You're right.
Is it what we see?
There are some
Black thing.
Yeah.
So why do people just all concentrate on 36% and 37%?
Because I mean, with 3,000 observations, I mean, when you have a third, the variance is going to be.
So they all respond 36%.
No, they don't. No, there is variance. So that seems very strange.
Yes.
That
That might have to do with Ukraine's war.
I'm not sure it has to do with the color scheme, but no. So yeah, bottom line, it doesn't look right because indeed there's quite a lot of variation. People.
These could be confidence intervals on your point on the estimate of the average, right?
No, these are really the raw data. Yes. Yeah. Okay. Good point.
That's 1/n times 2 nines. So if you have n equals 3,000, it's going to be small.
Yeah, but there's quite
The variance is
quite big in the. Okay. So let me first show you the average Friedman effects. I'm not going to spend too much time on it. What I'm really interested in presenting is the second part, which is proposing the model of sharing and estimating it. So the average Friedman effects are quite interesting, though. So here is the average sharing of the false, and here is the average sharing of the true, and how they vary by treatment. So first, let's look at the false. So every treatment reduces sharing of the false. And we see that actually the effects of, so extra click, I'm not going to talk much about it because it turns out that in experiment it doesn't work very efficiently at reducing sharing. I'm going to talk mostly of these three others. So this is priming, the nudge, this is fact checking, and this is asking to assess tweets before you share. So we see that the effect on the false is pretty much exactly the same. So people reduce by 40% their sharing decision, more or less. And it's very similar. And by the way, this third treatment that we had used to check whether people had motivated beliefs actually works very much as a nudge. You ask people to evaluate veracity before they share. So you're nudging them to think about veracity. So you see that it's quite similar in its effect. Where they turned out to be very different is in the sharing of the true. The true sharing of the true actually increases when you prime people, and it decreases when you offer fact checking. Okay, so if you take this at face value, it seems that you have one policy that seems completely dominant, which is nudging. It doesn't affect average circulation, and it just reshifts towards the truth. People share more the true and less the false. Okay, and it's very cheap to implement. But before jumping to this conclusion, we need to understand the underlying mechanism and why, what's driving this effect, and what's driving people to share in the first place. Yeah.
Do you think those baseline sharing propensities, like 30% roughly or whatever, if my eyesight is up to it.
Yeah.
Do they strike you as
So-
the certainly is very high?
They're very high. Yeah, they're very high, but they're very consistent.
It must be higher than the population, no, or are they?
No, it's much higher than what you observe, in particular for, so it's very high, but it's very standard for this kind of survey experiment where people have a higher likelihood to answer that they. So it goes down significantly. So our final sharing rate on Twitter is in the order of 5%. Okay, even less for the false. But this is standard for these kind of survey experiments where you do the reporting online, and there's still information you capture. So again, all this, what we're going to be interested in is the departures from this. But you're absolutely right here. So let me jump this. Okay, so let me go to what I'm mostly interested in, which is estimating the underlying preferences for sharing and looking at explaining these average treatment effects in a systematic way. So what is this model going to do? This model is going to be a model of partly influence and reputation. So people are going to care about three things. So the senders of the information are going to care about three things. First, when I share something that I think might be false, what could be the reputation cost I incur? Reputation of circulating false things. Second, do I share things to influence people? And third, do I share things to show that I'm a true Republican, for instance? So show my identity as a Republican. Okay? These three things, these three motives, I'm going to include them in the model, and then try to recover the indirect utility as a function of your estimate of veracity and your estimate of partisan alignment. So let me go into the model. So you have a sharer of a news that I'm the sender I, and an audience that are the receivers K. Okay? And the receivers are going to take a political action, some kind of action, AK, that I don't observe in my data. Okay, so I don't observe what happens to people who obtain the information. But that is part of the model. So it's what finally will you care about influencing. So they're going to take a final action AK. The state of the world is unknown. Theta could be 0 or 1. If it's 0, the democratic action, what I call the democratic action, AK equals 0, is optimal. And if the state is 1, AK equals 1 would be optimal. And you have this political content, so a tweet J, that the sender may choose to send or not, Sij equals 1, and is potentially informative on the underlying state theta. Okay? The utility of the receivers is going to be very basic. The receivers are going to have a payoff, which is maximized when the action conforms with a posterior on the state theta. So they want to decrease the distance with the actual state. Okay? So they want to match the state with their action. Yeah.
You have no gain of sort of conforming with the majority, like others, because in reality, I mean, they see whether such a tweet has been retweeted thousands of times or not.
Okay. Let me get back to when I show you the preference, the utility function, to see if it's captured partly. It's not going to be directly captured, but I'll tell you when I show the utility function. Okay, so, yeah?
But I mean, just one thing, I mean, to disentangle how much people care about, the reputation,
Yeah.
looking partisan, you could also have imagined priming them in this direction. Right? I mean, doing an experiment which will say, be careful, you will, it will affect your reputation. Remember,
well, so okay, so we could have done a more direct priming. We're going to show that the priming that was done through that is going to prime the reputation motive.
I see.
Okay? So in fact, it works exactly like that. Maybe it would have been stronger if I told them directly, be careful, you might look like a fool if you circulate false.
Yeah, or,
But I'm not clear whether it would be stronger than that. I'm going to show you how it shows up. So now, how do I understand in the model these two things that I identified in the data? So what is veracity? So there's an underlying state on the tweet J. J could be true or false. That's the state of the tweet. Omega J can be 0 or 1. And nu ij is the sender's belief that the content is true. And so I'm going to distinguish to capture this question of reputation. I'm going to differentiate people who are informed. That's type I with probability you are of type I with probability Q, or you are uninformed. You're type U with probability Q. So the informed individual sees the state of the tweet. He knows whether it's false or true. Okay, that's the informed. And the uninformed, to simplify the model, we assume that they all share a common prior on the veracity of the tweet. So if you are so there's 3 levels of beliefs, if you want: 0, 1. So that's the informed who know it's either true or false, and new J0, which is the uninformed belief on the veracity, which is J specific. So that's the veracity that we measure in the data. Partisan alignment. Well, we measure in the data this partisanship of the content. It's the evaluation of individual I of how much it's likely to influence, to be perceived as a Republican or Democrat favoring information. So it's the belief about how receivers would perceive the tweet J. Okay? And we also have a partisanship of the sender. Senders are going to be heterogeneous in the belief about the underlying state of the world. So you can understand it as being more Republican or more Democrat. The higher the PI, the more you're Republican, the lower, the less you are. And what I'm going to be interested in, what's going to turn out to be important in the model is this alignment measure, which is the alignment between my ideology and the tweet's ideology. Okay? And it's because I put symmetry on the J, I'm going to center them around 1/2. So it's if I'm a Republican, this will be 1. If I think it favors Republican, this will be 1. So it's going to be positive if I'm more aligned with the tweet. Okay, so these are the 2 things I'm going to measure in the data. And what I'm going to see is can my model recover an indirect utility function that depends on these parameters based on equilibrium of the model and updating of beliefs by receivers. So now I can come to Thierry's question. So here's what I care about. Is most important slide probably is what are the sender's preferences. So if the sender decides to share a particular news, what's going to happen in the model? In the model, people update their beliefs about the state of the world. Okay, so it's going to influence the action they take. But we also update their beliefs about, first, whether the sender is informed, okay, type I or type U, and second, what is the political alignment of the sender. So the alignment is supposed to be unknown by the receivers, and they update based on the fact that you share a particular piece of news. Okay, I'll finish and I get to it. And so the sender's payoff is going to be the sum of 3 things. First, there's going to be a partisan persuasion payoff. I get utility from influencing your decision, from driving you in my direction. Second, a partisan signaling payoff. I get utility from being perceived as partisan, so as being a Republican if I'm a Republican. And third, there's a reputation payoff. I get utility from being perceived as informed. So for a Republican sender, it would write like this. You have a tweet fixed effect. Characters of a tweet that might make people more likely to share. And then there's these 3 motives. First one is the reputation. I'm a Republican, so I care that you take a high action. I get payoff from you taking a high action. Second, I care for you perceiving me as a Republican. And third, I care you perceiving me as being informed. Okay? So, yeah.
So, I mean, I guess you're going to recover utilities, you're going to figure out people are like this, but from introspection and other things, I can imagine that there would be people who would get utility from being perceived as non-partisan, so can there be a negative weight on the partisan thing? And secondly, if what you really wanted to do is to affect other people's beliefs, actually, I can imagine it might be more useful to be perceived as non-partisan, because then it's the signal. Okay, so there's 2 things. So your second story is a dynamic one. Once they update, how I could impact them through future circulation. Here it's not dynamic, so it's not. On your first thing, I don't think it's people who would really want to be perceived as Democrat if they're Republican. There are going to be people who don't care about this motive. I think a lot of people might, well, academics, for example, might want to be perceived as non-partisan. Quite a lot of them might be, actually.
Okay. But non-partisan, it depends what you mean by non-partisan. Non-partisan for me is μs equals 0.
Yeah.
It means I don't care about you perceiving me as being of a particular type. It's not that I want you to perceive, it wouldn't be a negative sign here. It wouldn't be that I want to be perceived as a Democrat when I'm a Republican. So just I don't care about this motive. So I think that should be captured. It's going to be heterogeneity in these parameters that I recover. Yeah?
Do you think people would have a utility, like a warm glow effect? Like, I just want to send this news which is super pro-Republican, or like, I hate Republicans, I just want to share news that says they're bad, regardless of whether the thing is true or whether.
But that's what I call influencing the action. So it's not exactly warm glow, but I don't care about whether these other motives. I just want to influence people, and influence can be seen as a positive. It could be a warm glow. I just really believe the state of the world is Republican. I want you to take a Republican action. You can interpret it as negatively or positively as you want, but it's in that motive. What is not in the motive is what Thierry says, I think. It's not directly there, this question of conforming to what other people do. But it's going to be implicitly a bit distributed over these different things. So I don't think it's directly there. Yeah?
So here, for example, drawing positivity from sharing truth. Like, I care about the truth. That would be conflated with reputation.
Yeah,
right?
yeah.
Okay.
Yeah.
It's like
Yeah. I could have put directly. So we really wanted to start from fundamental.
like on my alignment.
Yeah. So now what I'm going to do is to show you how this maps to an indirect utility function. But I could have put in the directly in there that it's just I have a taste for truth, and I put it in my utility function independently of the detailed updating that are made by receivers. So anyway, we solve for this. So it's a model where you make your choices and inferences are made in equilibrium. So we derive the perfect Bayesian equilibrium of this game, and we find that the equilibrium is defined in cutoffs where senders share only if and only if the partisan alignment is high enough. So it's above a certain cutoff in Pija. And we find that we can write the indirect utility in terms of just these two parameters and the interaction between the two. So we find that we can write the indirect utility in this form, where it's a positive weight on veracity, it's a positive weight on alignment, and a positive and a weight on the interaction between alignment and veracity. So let me explain where this comes from the model. So the first term just comes from reputation. The more I believe the state to be true, the more it's likely that I will get a good reputation from sharing the news. So the reputation motives drives me to share things that are true. Okay, that's very intuitive. Second, to influence people in my direction, I want to share things that are aligned with my motive. So Pij it's going to be increasing in the alignment. The more it's aligned with me, the more I'm willing to share to influence people. What's ambiguous is the interaction between veracity and alignment. This goes in opposite effects when I want to persuade and when I want to signal my identity. Why? Because if I want to persuade, it's better to share something that's true. Because people discard, if they know it's false, they're going to discard it, and so you don't influence them. Okay? So then it's a positive interaction between alignment and truth. But if I'm willing to signal that I'm a Republican, strong Republican, in the model, what I actually want to do is to send something that's actually false. Because the more likely it is false, the more likely it shows my strong Republican alignment. Okay? And so the alpha 3 is going to be determined by the balance between these two motives. Okay? So what we have is we recover this indirect utility function that we can directly estimate on the data. And of course, we can invert the model to recover these weights that I'm now going to show you in the estimation. Yeah?
The functional form of phi comes from the model?
ij, why we recover exactly this far? Exactly, comes from model. Yeah, yeah. That's what we're mostly happy with. Yeah, it's that you recover exactly that from the model. I'm not giving you all the details of the model. There's one thing that's important is the symmetry. Why it's centered around 1/2 is due to the symmetry in beliefs, but that could be adjusted. I think you could have a transformation of this. But what I find very nice about this is that you can recover all these things from just the Bayesian updating model, the Markov perfect equilibrium. Okay. So then what do? We consider we're going to recover these parameters based on a nested decision. So first we suppose people make a decision between sharing or not. Okay. And then within when they decide to share, they decide which one to share based on the indirect utility they get from sharing J. So this is so in the lower nest, the utility we take is the indirect utility I just showed you. And then you might have an upper nest cost of sharing that may vary by treatment. Okay, and so we estimate this using the usual nested logit structure. Okay, so 15 minutes. Let me show you the results. But before I go to results, so there's 3 things that are very important. How would the different treatments affect my model? Okay, so if I go back to my treatments, how would they impact the model? So first, there's an updating effect. Normally, if I give you fact-checking, you should revise your belief on veracity and potentially alignment. Okay, so there should be an updating effect. I revise my belief. Second, nudging, and I think it's one of the first papers that sort of estimates structurally nudges. Nudging should make these different factors more or less salient. Okay, so it could change the weights you put on these different factors in your utility function. Okay, and finally, it could affect the cost of sharing in the upper nest. Why? Because all these frictions of making you process the information might just make you tired of sharing, and you might decide to choose the non-sharing option, more likely to be choosing the non-sharing option. So, let me show you now the result of the nested logit estimation. So first, that goes to Kevin's question. What happens to veracity? So I'm sorry, there's still a lot of bars. I'm going to reduce the number of bars afterwards, but let's focus on the 2 so nothing happens, more or less, in updating, except for these 2. Which is the nudging and the fact-checking. When you expose to fact-checking, logically, you update your beliefs on the false downwards. Okay? But you see, going to your point, the effect is pretty small. So people update, but they definitely don't go to 0. Some people don't update at all. And the effect is overall quite small. Interestingly, but that's really due to the design of the experiment, and so we can correct it when we do simulations. You also update when I give you a priming. And that's logical because it's within the experiment. I tell you, be careful, something is wrong. Something might be wrong. You realize that people don't tell you that for nothing, and so you do update as well. What I find striking is that even though I don't tell them which one is wrong, they update precisely on those that are wrong. So it's as if they had a good model of how the designer would do an experiment. Okay? But that we can correct because that's really an experimental design thing, and we can correct when you do the simulations. So what I want you to take out from this is that there's very little updating. So people don't really revise their belief that much, even when they face with fact-checking. What really is happening is the salience effect. So this is the lower nest. So it's when I've decided it's the multinomial logit estimation for those who decided to share. So let's look at first the control group, and that tells you utility of sharing. So all these 3 factors matter. And in fact, so you care about veracity. You also care about how aligned it is with your thing, and it's positive interactions. So it suggests that it's more important to influence people rather than signal your identity. So on average, the signaling identity seems to be dominated because this alpha 3 is positive. So that's sort of recovering the utility function of sharing in the model. So it goes a bit to your question: is do people care about truth? Well, they do care, but it's a trade-off. They care about truth, but if it's really very aligned, they're going to sort of give up on truth. Okay, and so that gives you the what the underlying utility is. What's quite striking is that when I look at these two, what really the treatments are doing is that they increase the weight that people put on veracity. And so the best way of showing this is actually to invert the model and show you the μ's. Okay? So I can recover the μ's from my model that map with the alphas that I have. And what you see is that the biggest effect is that in the treatments of fact-checking and priming, reputation concerns go up. So the weight you put on reputation, mu R, goes up relative to the weight you put on persuasion. So you're making people care more about reputation when you prime that thing. Yeah, Thierry?
Each of those is a separate regression, right?
Each of those is a separate regression, absolutely.
So
Yeah.
each of those
In the final, so we've also run it as interactions. You could also do the alpha interacted with treatments. So here, what I'm presenting you is separate regressions. Yeah.
So, but each of those has an underlying heterogeneity shape parameter on, the inertia.
Yeah.
And so each of those, those guys might have different levels of heterogeneity. So when you compare, as you do in the next one, the μ's are actually μ's multiplied by this heterogeneity parameter. Because there's no direct utility shifter in your model that gives you this.
So the assumption we do is that there's no shift directly of the treatments on this heterogeneity. So it doesn't shift.
Exactly.
Yeah.
If you had a shifter, you could estimate
well, we don't.
the heterogeneity parameter and get the μ's, get the structural μ's.
Yeah.
But here it's μ's times this heterogeneity.
If you want,
Which might be constant.
So I guess we could check it, but we're making the assumption that it's constant. Yeah. When in this graph, absolutely. Yeah.
Yeah? I was thinking about, somebody who tweets a lot,
Yeah.
might care more about his reputation or her reputation than somebody who is only occasionally retweeting.
Yeah. So how these μ's vary by characteristics, we haven't gone down to the bottom of it, but there seems to be, and that links to networks. You might think that the size of your network might make the reputation motive more important. So it could play in very different ways. There doesn't seem to be something very striking that comes out for the moment when we look at these variations. But I think that's the direction we want to take, is understand a bit better how the different motives vary by the characteristics of the individuals.
So another question?
Yeah.
The interpretation of reputation here, can you see whether things are retweeted? So suppose instead all I wanted to do is maximize the probability of retweeting.
Yeah.
Or
like in an Acemoglu model. Yeah.
And that would still come out. It could be that it looks like reputation because true things are retweeted more frequently than false. So if I'm selecting, I want to, I don't like to retweet things that don't get attention, and I like to retweet things that do. And if I have a partisan following, I'm more likely to put things that are partisan and likely to be retweeted.
Okay.
So it's just a different interpretation. It's not obvious. It's reputation as much as I'm just motivated by activity that I get from my followers.
Okay. So that's true within the model. I think that's true, and we don't have that dimension because there's no the model doesn't have that. Actually, we're thinking of making it more dynamic and seeing whether.
Can measure whether these things are retweeted.
Yeah, we can absolutely, but it was unlikely within the experiment to influence people because it was very small amounts at that time. And plus, they reported normally they could see the tweet before and the number of retweets before making that decision, but the numbers were so small that it was unlikely to influence them at that point. But within the model, I think it's an important dimension that we should take into account. And second answer is this priming is unlikely to shift that concern. So the fact that the weight you put on this increases when I just tell you beware false stuff is circulating is rather a shift on we see it more as a shift on reputation than a shift.
It still prime me just to think about whether this is going to be retweeted.
Yeah. Yeah, you're right. Yeah. No, so it's a good point. Yeah, we'd be interested to get that. But what we definitely see is you have this shift on that model. Finally, when we look at the upper nest, there seems to be an increase in the cost of sharing in the upper nest. That's more important for the fact checking than for the prime fake news. So there seems to be a computational cost when you give them fact check, a computational cost that just moves people away from even considering sharing. Okay. So let me show this a bit in. So let me do two things. I have 5 minutes left. So first, the role of the model is to see the contribution of these different channels. That's the first role. And then the second is to do counterfactuals. And I'm going to do a counterfactuals of what would digital literacy do within that model. Okay. So first, let's look at the contribution of different channels. So this is my average treatment effect. And here I've just kept the two policies I'm focusing on, which is priming and offer fact check. So first, when I just keep, so I'm going to keep one channel only. So if I only keep the updating channel, you see that pretty much nothing happens. So fact-checking doesn't work because people update their beliefs. That's the first thing. It's just doesn't, it's not the process through which fact-checking works. Yeah?
So related to this, I was wondering the fact that they're quite good at getting what's true and false.
Yeah.
Maybe it's also related to the kind of information that they got there was quite easy to figure out.
Yeah.
Something more kind of ambiguous.
Yeah.
That would be interesting where...
So it's exactly what so in the new, quickly, a new experiment we run during the presidential, we actually had 10 tweets of each type. So a lot of variation. And we also randomly paired pictures. Here we have set pictures. And we randomly selected for each group, like Republican true, Republican false, we randomly selected one of each. So tweets are going to be more or less easy to, and what we exactly observe what you say is that for some they're very good, and for some they're not really sure it's true. And why I'm not presenting it today is because we're still trying to unpack. The result seems to be overall confirmed, but I'm trying to unpack a bit what's the role of this intermediate veracity in a sense. But that's going to be very interesting to see this heterogeneity. Yeah.
And about this veracity, have you tried also looking at the effect of the actual truth, not people's perceived truth, but actual truth? Because otherwise you could have some situation where people who are more sure that something is true also more prone to retweeting.
So here what really I care about is your individual belief whether it's true or not. And it turns out that on average it's correlated with the truth. But here what I'm exploiting is individual time tweet variation in the characteristic. So it's whether I think this is more true than the other at the individual level.
I'm thinking about the correlation between partisanship and veracity, where when you're very partisan, you're also much more likely to believe that things are true. And there is your interaction.
Okay, so whether the two are correlated. No, so that's a good point. That's maybe we can talk a bit more about it. But yeah. So updating seems to basically not play a role. What salience? You see what salience does is you increase the motive of reputation, so you share more the true, and you share less the false. And salience is pretty much what's driving the effect of fact-checking on the false. You make people think of truth, and they're already pretty good at designing it. And what makes our initial average treatment effect, where it was going up for the truth, is that it's computationally less difficult. It seems that there's an upperness cost that's much lower for the prime than for the fact check that creates this final average treatment effect. Okay? So two messages. Updating is very small. Salience is what is driving the thing, and there seems to be a computational cost from the two. Let me just conclude on one thing, because I'm close to be out of time. We did So our model can be used to do counterfactual. I'm going to just show you one, which is, it's a bit abusive, but I'm still going to do it. It's to say what would happen if I did digital literacy training, and how do I understand it within our model, is increasing the probability of being informed. I increase the Q. In the model, this does two things. It makes people more aware of veracity, but it also makes them realize that the receivers are going to be more aware. So there's a direct effect on your evaluation of veracity, and there's an indirect effect that you're more likely to be detected by receivers because they are trained to notice. And so what's interesting is that indeed digital literacy training, when I increase Q, it does decrease the false circulation and increase the true. But when I do the relative importance, it's not because people are more informed that it works in our model and with the parameters we estimate from our model. It's because people realize that those who receive are more informed, and so they care more about this reputation motive. Okay, so given the weight we have on the reputation motive, it's the biggest driver of the success of a digital literacy training procedure within our Bayesian model, where people update on these beliefs. So that's the two things we use the estimates to derive. Okay, and I'm going to conclude there because we're out of time. Yep.
An interesting thing that you could do is, do you have information on their Twitter activity?
We have, yeah.
If you reweight your sample to mimic a more Twitter-like kind of respondent,
yeah, that's great. Yeah.
Could you run your estimation separately for like these kind of populations to see if they look a bit like the average person, or there's a very strong selection, and maybe you wouldn't get that?
Yeah, absolutely. No, so that's a good idea.
And they don't care about reputation.
Yeah, it's a very good point. So we need to dig now into this kind of heterogeneity. We've been focusing on these other aspects for the moment. Yeah, that's a great suggestion. Yeah. Okay, I'll close on that.